azo die. And the use of the word azo simply tells you that you have two benzene rings that are linked together by an N double bonded to N. That is what All right, so we're now going over to the next selected drug in our list of drug after benzocaine, and that is sulphanilamide. All right, so sulphanilamide is one of the members of the sulfonamide group of antibiotics, which I refer to as sulfur drugs. Yeah, they refer to as sulfur drugs because they contain sulfur in their structure. So there are a lot of sulfonamide antibiotics you get to encounter in pharmacy school. More details will be given to you when you begin to deal on the bacterial drugs, antibiotics generally under chemotherapy and the likes in pharmacology, another aspect of pharmacy. All right, so sulphanilamide is the first member to be discovered. Now, I need to help you understand something. So when you are being asked, what's the first sulfur drug that was discovered, you'll most likely find Prontosil, and that is very correct. So Prontosil is the first sulfur drug that was discovered. It's a dye. It's a dye. It's an azo dye. And the use of the word azo simply tells you that you have two benzene rings that are linked together by an N double bonded to N. That is what azo refers. So once you say N double bonded to N, and then you now have like benzene ring, that's azobenzene kind of compound. So that's the meaning of azo. So Prontosil is an azo dye, and it was the first that was discovered. But the thing is that Prontosil by itself does not have any antibacterial action. So what Prontosil is a prodrug. It's a prodrug in the sense that Prontosil breaks down to sulphanilamide, which is what possesses the antibacterial action. So when I say sulphanilamide is the first member to be discovered, I'm still saying Prontosil is the first member to be discovered, but that is the active ingredients that follows from the transformation of Prontosil, which is a prodrug, into the actual drug. So yeah, depending on whatever your thoughts by your lecturer, do well to follow that in answering your question, but I hope you did understand that. So the azo reduction of Prontosil will give rise to sulphanilamide. So what we have here is the structure of Prontosil. So we have two benzene ring here. Then we have the different groups that are there, and then we have the azo group. So azo reduction simply refers to the cleavage of the two N bonded, like double bonded end to end from the different benzene group. The moment there's a cleavage, we call that azo reduction. And I said that this compound we have here is Prontosil, which is the azo dye. So we have Prontosil. So the moment it is cleaved, this N will take on two hydrogen to form an amine group. This N is going to take up two hydrogen to also form an amine group. So the moment this N takes on two hydrogen to form an amine group, what you now have is this. So you have this, and then you are having your sulphanilamide. So take note of a variation in the spelling of sulphanilamide. Some other persons can choose to spell it as sulphanilamide. So whether you're spelling it as PHA or as F, you are still very much correct. So this is sulphanilamide that is gotten from the prodrug Prontosil, which is an azo dye, as we have explained what the meaning of azo is. So that's sulphanilamide right there. So sulphanilamide has a structural analog. It's a structural analog of PABA. We already know what PABA is. PABA is para-aminobenzoic acid. So why would we refer to it as a structural analog? When we say structural analog, it means something that is similar in terms of structure, because there's only one substrate that differentiates PABA from sulphanilamide, and it is the substrate on this part. So so we have the benzoic acid, and then we have the amino group on position 4, which is para position. You know how we do our numbering on a regular day. So this is 1, 2, 3, 4. So this is auto, this is meta, and this is para. So that is para amino benzoic. You can always draw this in different formats. You can decide to draw it this way. These things are not like it's not fixed. So you can decide to draw it this way. Yeah, you can decide to draw it this way. You are still very much correct. The reason, um, right? So, oh, sorry, I made a mistake here. So this is supposed to be two, and this is supposed to be two. That's the amine group. So you can always number it. You just know that this is 1, 2, 3, 4. This is 1, 2, 3, 4. If you choose to go this way, 2, 3, 4, 2, 3, 4. So that's the power position. So all of these things are all the same thing. That's para amino benzoic acid. So the moment the benzoic group is replaced by this functional group here, what you now have is sulphanilamide. So that's why we call it a structural analog. So the next thing we're going to be doing is the synthesis of sulphanilamide. So let's make progress.